Okay, my name is Andrew Molina,
And I'm Mackenzie Moore.
and we are creating a video for the group assignment for Phil 240. Starting with the definition of conditional probability and its calculation. The word definition for conditional probability is the probability that one event has occurred, A, on the condition that another event has occurred, B. The mathematical form of this written definition is PR, which means probability of A conditional upon B. The calculation of conditional probability is the probability of A conditional upon B is equal to the probability of A and B divided by the probability of B, which is notated below that as PR parentheses A forward slash B equals PRA and B forward slash PB. The only stipulation for this equation is that the probability of B must be positive as you cannot divide by zero. Before getting into Bayes' rule, I will derive Bayes' rule from what we know about the probabilities. So, um, we know that the probability of H and E is equal to the probability of E and H. Um, because of this, we can expand this equation to say the probability of H and E times the probability of E over the probability of E is the same as the left side of the equation on top. And expanding the equation on the right is probability of E and H times the probability of H over the probability of H. Going back to our definition of conditional probability, which I will rewrite at the bottom here in terms of A and B, is the probability of A conditional upon B is equal to the probability of A and B over or divided by the probability of B. And I will switch colors to show that this is of the same form as this and this. So this equation, or this part of the equation and this part of the equation will be able to be rewritten as the probability of A conditional upon B. So starting over and rewriting those parts of the equation, we get probability of H upon E times the probability of E is equal to the probability of E conditional upon H times the probability of H. Um, uh, Making this our equation, you would just simply need to divide by the probability of E on both sides, in which you get the probability of H upon E times, no, not that. Excuse me. Oh, no. Probability of H conditional upon E is equal to the probability of E upon H times the probability of H over the probability of E. To further simplify this, we will find what we can substitute for the probability of E, which given the principles of H being both mutually exclusive and jointly exhaustive, is that the probability of E is equal to the probability of E upon H times the probability of H plus the probability of E conditional upon H times the probability of not H. And I did forget the not H here. So in the original equation, we can substitute the probability of E for this portion. So rewriting all of that would be PR, or the probability of H upon E is equal to the probability of E conditional upon H times the probability of H over the probability of E conditional upon H times the probability of H plus the probability of E conditional upon not H times the probability of not H, which is our next slide. Bayes' rule is the probability of H conditional upon E, which is equal to the probability of E conditional upon H times the probability of H over the probability of E conditional upon H times the probability of H plus the probability of E conditional upon not H times the probability of not H. The purpose of Bayes' rule can be to calculate the probability of multiple events or calculating the probability that that events can be updated, similar to the Monty Hall problem.
All right, so probabilities in Bayes' rule, like Andrew said, there's the formula right there. And so the problem one probabilities that we need to find is the probability of blue in the crash and then the probability of red in the crash. Next slide. Okay. So for our problem one setup, our situation basically is that Cynthia has been randomly assigned 3 different assignments for software packages in order to solve an accounting problem. So for the first one, 1 out of 10 was blue, 3 out of 10 were orange, and then 6 out of 10 were red. And so that's for the assignment probabilities. And then for the crash probabilities, red crashes 10% of the time, orange crashes 2% of the time, and blue crashes 3% of the time. Okay. And then for our final calculations, we have the probability of the crash is equal to 0.6 times 0.1 plus 0.3 times 0.2 plus 0.1 times 0.3 equals 0.15. So for the probability of the red crash, we have 0.6 times 0.1 and we get 0.4. And then for the probability of the blue crash, we have 0.1 times 0.3 divided by 0.15, and then we get 0.2. So that means that the probability that Cynthia was assigned a red is 40%, and then the probability that Cynthia was assigned a blue is 20% for her packages. And I think that's all for the final problem.